Guys, stop everything. New images and records have arrived that truly change the story of this interstellar visitor, Atlas. I saw them, I analyzed them, and today I'm going to tell you, firsthand, everything these photos, sounds, and calculations are revealing. Grab some popcorn, because what follows mixes astronomy, hard physics, and a little of that "are we really alone" feeling. In the past few days, amateur and professional images, from half-meter telescopes to larger observatories, have shown a bright coma with a narrow anti-tail pointing toward the parent star of our solar system and a tail stretching tens of times farther. Additionally, strange sound recordings have come from Ganymede, along with a set of calculations that, if correct, make this object's behavior incompatible with a natural comet as we know it. I'm going to break down each point for you: technical details, alternative hypotheses, and most importantly, which observations will ultimately decide it all. Before diving into the math and radical possibilities, grab a cup of coffee, settle into your chair, and follow step by step. I'll keep everything clear, explaining each key term, and at the end, I'll recap the 12 anomalies that already form a disturbing dossier on Atlas. Images taken between November 22nd and 24th, 2025, by amateurs and some professionals, captured an extensive coma with an antitail directed toward the parent star of our solar system. In one of the best images, taken with a half-meter telescope, the tail is estimated to reach about 5 million kilometers, while the antitail extends to roughly 1 million kilometers. For scale, at the typical thermal speed of sublimating gas, around 400 meters per second, crossing 1 million kilometers takes about a month. This extent is crucial. The antitail appears to have enough momentum, or thrust pressure, to penetrate the solar wind, whose typical flow speed is about 400 kilometers per second. Since dynamic pressure scales with the square of velocity, this implies that the mass projected by the antitail in the outer region is millions of times greater than the local solar wind's typical density. In other words, we're seeing an amount of matter being ejected that, if explained by natural sublimation, demands nearly impossible numbers. Moreover, non-gravitational acceleration was detected near perihelion, with very high statistical significance. Reports indicate detection at about 10 standard deviations according to databases like JPL Horizons. This means that, at that critical moment, the object received an extra push that cannot be explained solely by the gravity of the planets and the parent star of our solar system. The Ganymede signal: sound, frequency, and reason for concern. A separate chapter: the radio recording at Ganymede. In 2020, the Juno probe detected a short-duration signal with frequencies ranging from 3 MHz to 41 MHz, according to the conversion used by those who published the sound. This range is far higher than what is typically observed from the natural process known as the cyclotron maser, which at Ganymede and in other observations, for example, the Galileo probe in 1996, usually falls between 30 and 80 kHz. Why does this matter? Because, if the natural explanation of this noise applies, electrons accelerating along magnetic field lines, the amplitude and frequency range of that 2020 episode was still abnormal. Practically speaking, a signal approaching bands used for human communication, megahertz, is, at the very least, something that deserves deeper investigation. And here's the cherry on top: a claim circulated online, in forums and anonymous posts, by a whistleblower that NASA had detected a damaged space station near Ganymede, a speculative and unconfirmed report. Even without confirmation, this story reinforces the need to seriously consider two hypotheses: the natural, magnetic phenomena and solar storms, and the artificial, technological structures or emissions, trajectory, correction, and the encounter with Jupiter. Or something like it. One point that made headlines in videos and discussions is the small trajectory correction that Atlas seems to have undergone during its passage near the parent star of our solar system. This change is subtle, yet sufficient for its path to lead it to a gravitationally interesting region around Jupiter, the so-called Hill radius of the gas giant, at dates predicted by different teams. Amateur observers mentioned a critical passage on March 16, 2026. Academic studies discuss this range with numerical precision. Why does this have implications? Because, if the object was adjusted by non-gravitational forces, the maneuver could place probes or structures at a stable point around Jupiter, where objects can pause relatively, use Lagrange points, or gain logistical advantages. Simply put, if it were an intelligent artifact, this would be the ideal point to leave long-term orbiting hardware or deploy devices for exploration and maintenance. But caution, there are natural interpretations for course corrections. For example, asymmetric mass ejections, jets, can alter an orbit. The problem is that the numbers calculated to justify the change by sublimation are enormous, making it implausible without fragmentation or mass loss far greater than the estimated nucleus mass. The math that bothers. Summary of key calculations. Let's get to the heart of the problem, without getting lost in signals and noise. Studies estimate that the total mass and mass lost in recent weeks correspond to billions of tons. Sublimating carbon dioxide in such quantities over a short period would require absurd energy values, orders of magnitude implying absorbing areas far larger than the apparent nucleus. The alternative proposed by Avi Loeb and others is that technological thrusters, chemical or ion propulsion, would produce exhaust velocities much higher than simple thermal sublimation. This drastically reduces the mass needed to generate the observed acceleration. Chemical reactors reduce the requirement by about 2 orders of magnitude, and ion propulsion by about 4 orders of magnitude. In other words, if technological propulsion were involved, the mass problem disappears, but this opens the much deeper hypothesis of an object with deliberate behavior. The role of amateur observers. Why home photos matter. Something fascinating about this episode. Amateur telescopes and independent observers provided decisive images. Names like Mitsunori Tsumura, Paul Craggs, Peter Carson Lee, and Elena Walter appear with important records. In parallel, footage from content creators and smart home telescopes brought immediate empirical data to the debate, either to confirm morphologies or detect rapid rotation and color changes. This changed the investigation dynamics. Today, a well-processed home video can detect an apparent nucleus, measure brightness variations, and even suggest rotations that large telescopes, due to operational constraints, did not capture immediately. It's a revolution in how observational science blends with the community, how we will prove or refute each hypothesis. What's next? The verdict depends on a few, but decisive, observational points expected in the coming weeks and months. High-resolution spectroscopy during the December passage, near closest approach to Earth on December 19, 2025, could measure jet speeds and identify chemical composition, crucial to distinguish CO2 sublimation or water vapor from technological exhaust. Images from Hubble, Webb, and large ground-based telescopes will provide sufficient resolution to see nucleus structure, detect fragments, and measure rotation precisely. Continuous monitoring of position and acceleration by astrometric centers, JPL, professional observatories, will allow confirmation of the magnitude and persistence of non-gravitational acceleration. Analyses of radio signals at Ganymede and the Jovian region, with coordinated surveillance, may confirm whether repeated emissions similar to the 2020 detections occur, and if so, determine their exact spectral properties. If these measurements point to exhaust velocities far exceeding thermal sublimation and to strange chemical signatures, we will be forced to consider technological hypotheses more seriously than ever. Hypotheses, from most conservative to most radical, casual natural, sublimation of huge ice pockets, and local solar winds explain everything. Less likely, given the numbers. Natural but atypical, unusual composition, rare gases, plus local magnetic behavior create unexpected signals and mass pressure. Accident, human artifact. Remnants of a mission or station. Speculative, little public evidence. Extraterrestrial technology, deliberate jets for maneuvers, possible probe deployment, or logistical colonization attempts on Jupiter's moons. Explains many signals but requires extraordinary proof. I present these hypotheses not because I think any of them is likely a priori, but because science requires us to compare models with data. And the data today leaves several doors half open. Recap: the 12 anomalies that remain unexplained. Before moving forward, it's worth reviewing the 12 points that remain beyond any conventional explanation. Memorize, share, and demand clear answers. Here's the full overview. Unusual trajectory. A retrograde motion aligned with the ecliptic, completely outside statistical expectations for interstellar objects. Directed antitail. Jets pointing toward the mother star of our solar system, forming an antitail that cannot be explained by viewing geometry alone. Massive nucleus. A body with much higher mass than expected for interstellar visitors, moving at high speed. Precise timing. Arrival moment allowed close passes to Mars, Venus, and Jupiter. A surprisingly coordinated timeline. Uncommon metallic composition. Plume rich in nickel, levels atypical for comets and the comparative comet. Reduced water fraction. Gas emission almost devoid of water, far below what is typical for a classic comet. Negative optical polarization. Strongly negative optical behavior, not seen in catalogued natural objects. Intriguing arrival direction. Alignment with the WOW signal region, a celestial coincidence that draws attention. Sudden bluish brightening, rapid increase in brightness with a bluish hue, different from known comet patterns. Energy discrepancy in jets. Jets would require an energy absorption area incompatible with the estimated nucleus size. Non-gravitational acceleration would imply significant mass loss without evidence of an ejecta cloud to justify it. Extremely collimated jets maintain direction over enormous distances, defying the expected rotation of such a body. Each point is alarming on its own. Together, they form a puzzle that science must confront with seriousness. It's not enough to attribute everything to instrumental noise. Directed investigation is required. Guys, I'm not saying we have the answer yet. What we have is a set of converging anomalies. Images showing vast antitail and tail, detection of non-gravitational acceleration, strange radio signals at Ganymede, and a course correction toward Jupiter. Together, these observations form a case that cannot be dismissed with a simple, "It's natural," at least not without solid proof. My honest take, the next few weeks, with spectroscopy and higher resolution images in December and continuous monitoring, will be decisive. If jet spectral curves with speeds on the order of kilometers per second or exotic chemical signatures appear, the natural hypothesis will be greatly weakened. Conversely, if everything fits complex sublimation models, we'll have learned something new and profound about interstellar bodies. So, what do you think about all this? Is Atlas just a weird comet? Or are we facing something that defies our understanding? Perhaps even technological? Share your theories in the comments. Speculate? Disagree? Bring data? I can check. Comment and share this video so more eyes can help watch the sky in the coming weeks. If you enjoyed this type of analysis, click, comment and share. Subscribe to the channel to not miss updates. We'll follow the December 19th, 2025 images and spectroscopic reports, and turn on notifications. I'll continue investigating and bringing everything to you, with seriousness, skepticism, and open eyes for the extraordinary. Until next time, and keep your eyes on the sky.